Hello, apes, and welcome to screencast number 7 in our Chapter 3 series, and this is Evolution, Biodiversity, and Population Ecology. So we last left off talking about habitats and the different habitat needs, and I was mentioning migratory birds use different habitats during their migration for summer and winter. We have robins are very common around here, and we see them in spring. I remember growing up and saying, oh, when we see the first robin, we know that spring is right around the corner. Robins feed off of worms and some other insects, worms primarily, and they will fly to warmer regions in the wintertime so that they can have access to the worms and the insects that they eat that the ground doesn't offer them to be able to get here during the winter. But I've noticed, and you've probably noticed too, our winters have been warmer. And I'm seeing robins come back early in February rather than late March, early April like they used to. So because of the change in climate, we're also seeing a shift in these migration patterns. But species use different criteria to select a habitat. So this is some of the things that we need to look at. The types of soil that are present. We live in the temperate forest region, and our soil is very, very rich. Humus, it's called humus. Not to be confused with hummus. It's humus, almost spelled the same. And it's very rich soil, so we get a great variety of different kinds of worms and grubs that live in that soil because it's so rich. The topography of the land. Is it flat? Is it mountainous? The types of vegetation that's there. Our vegetation, we have deciduous trees, and that means that in the wintertime, our trees lose their leaves, and in the spring and the summer, they get their leaves back. So the vegetation that's available and the other species, what other species are there, because they could be predator species of them as well, or they could compete for the same resources. So that's something else that we have to take into consideration. If we're talking about an organism that lives in water, then we've got to consider the water temperature, the salinity of the water, the depth of the water, the flow of the water. All of these things can determine what kind of species could live there. If we're talking about a fish, like maybe one of those blowfish that are really nice and round, it's probably not going to do well in a flowing water ecosystem because it's fat, it's big, and it's going to be caught in the currents. But if we're talking about a trout that's streamlined, that's going to be able to swim against the current and offer not as much resistance, it's going to be able to thrive in that area. And again, that the presence of prey is also important. So species survival is going to depend on having that suitable habitat where they can thrive. You've heard of the term niche before, and this is kind of like the job. What role does an organism have? It's the summary of everything an organism does. So that is, where it fits in the food chain or the food web, what its job is, how it uses the resources in its habitat, the functional role in the community, the food selection, where it is within its energy flow. We've talked about being predators. We've talked about being herbivores or carnivores, and that is a role. And the interactions that it has with other individuals is important. And you've probably heard sometime or another, oh, I'm so glad Bertha found her niche. She found the place where she belongs. And it's along the same lines. It's that role, it's the job that organism has. So that specialization is also a means of survival for these organisms. And we need to understand those roles, because if we start removing organisms from these habitats, then that habitat's going to fail. It's not going to be able to survive, and we're going to wind up with ecosystem failure with that. We have organisms that act as specialists within an ecosystem. So that means that specialists, they really have a very narrow job, and that they don't usually go out and beyond that job because they have specific needs in order for their survival. These specialists are extremely good at what they do. Just going to pause for a minute. I'll be right. I'm back. Okay, so we were talking about specialists, and they're very good at what they do, but they're very vulnerable to when conditions change. So those honey creepers that we were talking about in the beginning of this chapter, they would be considered specialists. And when their environment changed, their numbers dropped drastically. Generalists are going to be species with very broad niches. They have very broad roles that they carry out, and they can fit into a wide array of habitats, and they can utilize a lot of resources. And because of that, they can live in many different places without any problems at all. So we've got another bird that is in the Hawaii area that's called the common myna bird, and this is a generalist. It has an unremarkable bill that allows it to eat many types of food, and it can go into many types of habitats. It's very widespread through the Hawaiian Islands, and it's very easily adapted. It's one of Hawaii's most numerous birds that we have. Okay, when we talk about population ecology, because population was one of those things that we needed to include in here, this is where you have individuals of a particular species that inhabit an area. So we're seeing the nene bird down at the bottom that kind of looks like a combination of a duck and a goose. These are species that may have different arrangements of their populations. Like the nene, it exists as an isolated population. Another pause. I'll be right back again if I can get this to pause for a minute. Okay, so this nene lived on the Hawaiian Islands as well, and when rats and cats and dogs and pigs and mongooses and other types of animals came in, they actually fed on the eggs and the young of the nene, and the nene actually disappeared from all of the islands except for the island of Hawaii. So in recent years, biologists and wildlife managers have really been trying to breed in captivity these nenes and reintroduce them to other areas of the islands. They've had a lot of success with trying to get the nene to repopulate. So that's been something that's good, but it kind of explains how you can get this isolated species. When we think of other species like humans, we exist as large continuous populations. And because we have the ability to use technology and to build and to think and create tools, we tend to overtake an area more than other species do. So populations will show characteristics that help predict their dynamics. And what that means is that there's certain characteristic of a population that's going to help scientists predict what will happen to them in the future. So we can look at their needs, we can look at the way that they utilize the environment, we can see if they're specialized or if they're more of a generalized type of species, a generalist, and we can see how they're going to use their environment, and then that way we can help manage those species that could possibly be threatened. So we consider when we're doing this the population size, and the population size is just the number of individuals that are present within a particular area at a given time. These populations generally grow when the resources are more abundant and the predators are few. So as long as they've got the resources available, they're going to continue to populate. So take a look at those Canadian geese. And we've got large areas of Canadian geese because there really isn't any natural predators in the area. There's been a few fox that have been introduced into like the grounds around Gwinnett and in Gwinnett, and they've been helping to keep some of the population numbers down, but they've really been growing without check. So we take a look at that and we take that into consideration. We also look at population size, how it declines in response to loss of resources. We can look at this in terms of natural disasters that happen. Hurricane Sandy that happened a few years ago. The introduction of other species that take up their place or use their resources. And we look at how that affects population size, and we use that in order to make the predictions. So here's a picture of the passenger pigeon. This was a very abundant type of bird that we used to put little notes on, and it would fly from one area to the other and deliver these notes and these messengers. And literally they existed in flocks like you see in this picture that was done. And what happened is we hunted and we deforested. We cut down the forest that they live in, that we actually drove this species of birds to extinction. This passenger pigeon does not exist anymore. We have other kinds of pigeons, but this particular one does not exist. So we can study the populations, and one of the things that we look for is population density, and this is the number of individuals that live in a population per a particular unit area. Is that 1 acre? Is it a square mile? Is it hundreds of miles? Whatever that unit area is, and we'll look at how many species or how many individuals of that species that we actually have. So let's say that I had frogs, and let's say there were 150 frogs that lived on a pond that was 3 acres in size. So 3 acres is my unit area. So if I wanted to know how dense it was, I would just take 3 and divide it by 150, and that would be 50 frogs per unit area. 50 frogs per acre live in that area. And that's what we look at. We look at population density. High densities have advantages and disadvantages. High densities, you can find mates easier. Okay, so that's great. The disadvantage is there's increased competition. There's going to be competition for food, water, and shelter that's going to happen because of that. There is an advantage where if there's larger numbers, you're less vulnerable to the predation that goes on. So that's an advantage. Another problem is there's a greater chance for transmission of diseases. If you're competing for food, there's a greater chance for starvation and diseases to be transmitted. This sometimes causes organisms to actually leave an area if it's too dense, and they'll go away. Low densities, however, provide access to plentiful resources and space, but it makes it harder to find mates, makes you more vulnerable to the predators, and can actually cause organisms to disappear from that area if there's too many predators. Coming to the end of this screencast, we're just having so much fun. They're flying by. All right, we'll see you in the next one.